Hello everyone. So let's start with today's session. So today I'll be covering one part of reinforced concrete design, that is design of pre-stressed concrete. So it is a very important topic for GATE, and yeah. So I'll start with today's session. So before starting, I want to know whether you are familiar with pre-stressed concrete design. Just familiar. You don't need to know everything. Just you know whether you have studied this during your BTech, this pre-stressed concrete design or not. Just you can write in the comments or maybe you can answer. I'll not ask anything, so you can tell me whether you know this pre-stressed concrete design or not. Just wanted to know how to, like, at what level I should start. Okay, so you have studied. Okay, so I assume Harini and Mayur have also studied this. Okay, so let's start with the basics. So I'll try to be as simple as possible. So before starting, let me give you a brief overview of what I'm going to tell you today. So first of all, I'll tell you briefly that what is pre-stressed concrete. I'll not go very deep into the definitions and everything. I'll just keep the things simple so that that much I'll share, which will be required for gate. Okay. So pre-stressed concrete, something about pre-tensioning and post-tensioning, and then I'll quickly tell you the difference between post-tensioning and pre-tensioning. Then reinforced concrete versus pre-stressed concrete. So what is the basic difference between these two, reinforced concrete and pre-stressed concrete? Then I'll tell you how to analyze the any pre-stressed concrete beam. So next, finally, we'll see the losses in the pre-stressed concrete beam. Okay, and then we will see one practice problem. So all the losses we'll not be able to cover today. I'll only cover this elastic shortening loss today. Maybe in the next upcoming session, I'll take other losses too. So it's very important type of loss. So I'll cover only elastic shortening loss. So one problem, practice problem related to this elastic shortening loss, and then two gate problems. One is gate 2017, set 2, question number 38. This is related to elastic shortening loss, and second problem, which is not related to any type of loss. It is just it will just consider only the pre-stress concrete basic thing. Okay, so we'll also use the deflection formulas which I discussed in the last class for this question number 46. Okay, so I hope it is clear. So I'll start with the today's class. So, what is pre-stressed concrete? So, basically, pre-stressed concrete, in the pre-stressed concrete, we introduce the internal stresses of suitable magnitude so that stresses resulting from the external loads are counteracted to a desired degree. To explain it better, let me draw one figure. Okay, suppose this is a plain concrete beam, a simply supported plain concrete beam. Okay, so when if we apply any load W on this beam, how will this beam deflect? So the probable deflected shape of this beam will be like this. Okay, so it will deflect somewhat like this. I hope this is fine. So it will deflect like this. This is a simple plain concrete beam with no reinforcement at all. So because of this deflected profile, or because of this loading, what happens is this part or the bottom part of the beam will be under tension because it is stretching, while the top part of this beam will be under compression. Okay, as we know that concrete is very strong in compression, but it is not very strong in tension. So it is brittle material and it suddenly fails in tension. Okay, so um, to counter this thing, what we do is we provide reinforcement. So that is the basic concept of reinforced concrete design. Why we provide the reinforcement? The first purpose is to take the tensile stresses in a concrete beam, and the second purpose is to provide ductility to the beam. Okay, so now what we'll do, we'll provide this reinforcement here. So we are providing this kind of reinforcement. Now what will happen if I apply load? When if I'll apply this load W here, this will again deflect like this manner. But now since the bottom part contains this reinforcement also, therefore this bottom reinforcement will take some of the tensile stresses, or because of which this beam will not fail suddenly. Okay, so this is the purpose of this providing this reinforcement. Up till now you know that, you know these things, right? Why we provide the reinforcement? Because this reinforcement will take up the tensile stresses. Now why do we design the pre-stressed concrete? Okay, so this is plain concrete, this is reinforced concrete. Now why there is pre-stressed concrete? So what do we do in pre-stressed concrete is we will provide this kind of tendon here, or steel tendon, or this is called tendon. Okay, so we'll provide this tendon. In this tendon we will apply this, we'll provide this kind of pre-stressing force. Okay, we'll provide this kind of pre-stressing force in the steel tendon at the bottom. So what do this tendon do, this compressed tendon do? This will transfer the compressive stress in the lower part, or in the bottom part of this concrete beam. This will transfer the compressive force. Okay, so why this concrete beam was failing? This concrete beam was failing because of the tensile stresses in the bottom part of the beam. But now we are providing, we are intentionally providing a compressive force in the bottom part of the beam. Because of this beam will be able to take much more load than than the plain concrete beam and the reinforced concrete beam, because it will fail a lot later than these two beams. Why it will fail later? Because of this compressive force on the bottom part of the beam. Okay, so this compressive force will counteract the tensile force due to this loading. Okay, so the main concept is of providing this pre-stressed concrete beam is, this pre-stressed concrete beam will, we will introduce some internal compressive stress in the bottom part of the beam, which will counteract the tensile force due to this loading. I hope it is clear. If there are any doubts, you can ask me. So you know, right? There's a plain concrete beam, there's a reinforced concrete beam, and even better, there's a pre-stressed concrete beam. Okay. So I hope it is clear. So that is the reason of providing the pre-stressed concrete, so that the beam will able to take more load and there will be less cracking. Okay, so the cracking will be was due to the tensile stresses, right? But now we are intentionally providing the compressive stress on the bottom part of the beam, because of which the cracks will also reduce. Okay, so that is the concept behind the pre-stressed concrete beam. So now there are two methods by which we can introduce the pre-stress or the compressive stress on the bottom part of the beam. One method is pre-tensioning, and the other method is post-tensioning. So let's quickly see what is pre-tensioning and post-tensioning. So there are two methods of providing or introducing the stresses. One is the pre-tensioning. So this is pre-tensioning method. So what do we do in the pre-tensioning? There's a pre-stressing bed. Okay, there are two end abutments, or two structures like this, you can say. So there is one tendon, there's a steel tendon here, which is shown with red color here, and there are two jacks. Okay, so this is already stretched. So this kind of, you can imagine a rubber which is stretched, and it is attached to these two abutments. So this is the initial setup for pre-tensioning. Now what do? We will cast, as we cast the concrete beam, we will cast the concrete beam in this part. Okay, we'll cast the concrete beam. Now what we will do, we will remove these two things. We'll remove these two jacks from here, and because of which this steel tendon will be compressed, right? If we suddenly remove these two jacks from here, so it will introduce the compressive stress in the tendon, so because of which the compressive stress will be transferred to the lower part of the beam. So this is a method of pre-tensioning. Okay, so our main motive of pre-stressing is introducing the compression on the bottom part of the beam. So we can do it with using pre-tensioning like this. Okay, so this pre-tensioning is usually used when we have to make many precast structures in bulk in the factory. Okay, so this kind of setup is there. We'll make a lot of beams like this and we will pre-tension it. Okay, there's another method when we have to cast in situ. So the second method, that is the post tensioning, is generally used for the structures which are cast in situ. Okay, so in this method, what we do, we will cast this concrete beam with a duct or with a hole, you can say, in at the bottom. Okay, now we will introduce the steel tendon in this duct or hole like this. In the second stage, we are introducing this steel tendon here. We will anchor this steel tendon on this part and we will pull it in this direction like this. So because of this pulling, it will get stretched. After sufficient pulling or after the desired level of pulling, we will cut and anchor it like this. Okay, so because of this also, the pre-stress or the compressive stress will be introduced on the bottom part of the beam. Okay, so there are two methods. Either we will stretch the tendons and then cast the concrete, or we will cast the concrete and then stretch the tendons. So that is the basic difference between pre-tensioning and post-tensioning. Okay, so there are different purposes in which we use these two different methods, but the main objective is the same. The main objective is to transfer the pre-stress on the bottom part of the beam so that the bottom part of the beam remains under compression. Are there any doubts till this point? Okay, this is just for, like, in the MCQs they can ask sometimes that abutments or this kind of things, or pre-stressing bed, in which techniques this pre-stressing bed is required, or this kind of questions. So these are the different stages of pre-tensioning and post-tensioning, you should know. Okay. Okay, so this is done with post-tensioning and pre-tensioning, and this is just the comparison which I've already discussed, the difference between the reinforced concrete and the pre-stressed concrete. Okay, so in the reinforced concrete, I've already told you, we are just introducing this reinforcement. We are not applying any kind of pre-stress here, but in the pre-stressed concrete, we are applying this pre-stress on the bottom part. Okay, because of which will encounter the the tensile stress which are generated due to this applied load. Okay, so two things you need to remember. One is the difference between the reinforced concrete and the pre-stressed concrete, that you might be asked in the interviews also. Okay, so this basic questions you should know. And the second thing is, what is the difference between post tensioning and pre-tensioning, and when are they actually used. Okay, so this was all about the theory part. Then we'll see what is how do we analyze the pre-stressed concrete beam. In between, if you have any doubts, you can ask me. You can either raise your hand or you can write in the comments. Okay. Yeah. So now how to analyze this pre-stress beam. So this is important for gate perspective. So suppose this is a concrete beam. This is the neutral axis here, and this is the with the green color. This is the tendon. Okay, so we have applied this load, pre-tension compressive force in this tendon in the lower part of the beam. Suppose now the distance between the neutral axis and this tendon is E. Okay, this is E. Now how do we analyze this pre-stress beam? By analysis I means how will you find the stresses at different levels in this pre-stress concrete beam. So in this beam, what you can do first, the first step will always be, you will shift this pre-stressing force to the neutral axis. What you will do, you will shift this pre-stressing force to the neutral axis. Okay, so better understand it. What you will do, suppose the pre-stressing force was acting at distance E. Now what we will do, we will shift this pre-stressing force to this here P. Now we cannot just simply shift it to this position, neutral axis. We also have to apply a moment. Okay, so I have told in the last class also, whenever you shift a load, you just shift a load by some amount, and then you have to also apply the moment. Okay, so I'll shift the load from here to here, then I have to apply a moment also. So moment, the direction of the moment should be, I'll draw. Okay, first I'll draw. So this is the moment. This will be the moment that will be there, and the arrow of this moment will be in the same direction from where we have shifted the load. So here we have shifted the load from the bottom. So I have applied the direction of the arrow is downward here. And what is the value of this moment? The value of this moment will be P into E. This shifting I'm doing only for the simplification of the analysis. Okay. So this actually this load is not shifting. Just for the analysis purpose, I can shift this load to the neutral axis, and I can apply this moment, which is PE. Just for an example, I'll show it to you. Suppose this is a beam, overhang beam. Okay, there's an overhang here. Suppose there's a load W here. So I can shift this load W for analysis purpose to this point B. Okay, so what I will do, I will shift this load W here, and I also have to apply a moment also, so that these two systems, to make these two system equivalent, I'll shift this load W here and apply a moment here. So the direction of this moment will be towards the point from where we have shifted the load. So we have shifted the load from here, so the direction of this arrow is here, like this. Okay, and the magnitude of this moment will be W into, suppose this length is A, so W into A. So this is how we usually shift the load. I hope you must be knowing this. This force transfer. Oh, this force transfer we can do anywhere. Just that we have to keep in mind that this force is actually not shifting. We are doing just for the analysis purpose. We are just doing this for calculating the stresses and all. Okay, so yeah, we can shift it for analysis purpose anywhere. So here it is P. So now you know, right? We'll shift this load to P just for simplification of analysis. We can also do that without shifting, but this is more much easier, okay, to understand. So we'll shift the load to here, and this will apply moment here. So it will be P into E. This distance was E, right? So it will be P into E, right? Now I'll analyze this. So there are now three cases, okay? So this is our final beam which I have to analyze. Okay, suppose there is some load also, UDL also, because in a beam there will be some dead load or some live load. Okay, so I have considered this load also. So now these are all the possible forces in my beam. So what I will do, I will analyze all the three cases separately. So what are all the three forces here? One is the UDL, one is this load, axial load P, and another is this moment PE, right? These are the three forces which are here, right? One is UDL, one is this axial load P, and another is this moment. There are no other forces, right? Okay. So I'll analyze all three cases separately. So the first one is the axial force. So what is the stress due to the axial force? How do we calculate the stress due to the axial force? Simply P by A, right? Due to this axial force, what will be there? There will be a compressive force in the entire cross section, right? I hope you agree with this. If I'm applying the axial force, there will be uniform force in throughout the cross section. Okay, so if I want to draw the profile of it, it will be this compressive force, and the magnitude of this compressive stress will be P divided by A. Okay, I hope you agree with this. The second thing is the moment. Okay, so there is a bending moment which is applied, and the magnitude of this is P into E, right? So how do we find the, you must have studied in the strength of materials. How do I find the bending stresses? The formula for finding the bending stresses is M by I into Y. You must have read it. Okay, so, and what is the value of M here? The value of M is P into E divided by I is the moment of inertia, and what is the value of Y? Y is the location where we need to find the stress. So if I want to find the stress at this location, this will be my Y. If I want to find it at any other location, if I want to find at the bottom, so this will be my Y. Okay, so y value changes according to where you have to find the stress. In most cases, we have to find the stress either at the bottom or at the location of the tendon. Okay, either at the bottom, so that bottom means d by 2, right? This will be d by 2, or either at the location of the tendon. So the tendon location is at E. Okay, so this so by at which location I need to find the y, that will this thing will differ according to that. Okay, so I'll for now I'm considering it y only. So m by I into y, this is the formula, and how it will vary this because of this moment. Please tell me if you agree. The bottom part will be under the compression and the top part will be under the tension, because it is in like this form, right? So this kind of moment will compress the bottom part, and it will generate tension in the top part. So this kind of profile will be there. This loading, this axial force was applying the uniformly distributed compressive load in the entire cross section, but this moment m or PE is causing the bottom part to be under the compression and the top part to be under the tension. If you don't understand at any point, please stop me then and there. Okay, so this thing, this load will be like this, right? It will have the bottom part under compression and the top part under the tension, which is okay, and the magnitude is sigma. Let's call it sigma for now. Sigma 2, sigma 1. Okay, now we have considered two cases. Now the third case is when there is a UDL. Okay, so because of this UDL, this beam will deflect like this, right? Downward direction. Okay, or this will cause the moment in this direction. Let us consider this moment. So this UDL, because of this UDL, this is a kind of moment that will generate in the beam in this direction. Okay, so this kind of moment will cause the bottom part to be under tension and the top part. So because whatever is the direction of this arrow will be under the compression, right? So this moment will cause the top part to be under the compression and the bottom part to be under the tension, right? So and the magnitude will be, the stress will be same, bending stress, because bending moment is applied, so bending stress will be there, and the magnitude will be m by I into y. But here the m will be due to this UDL. Okay, so the magnitude is m by I into y, and if I want to draw the profile will be top part will be under the compression and the bottom part will be under the tension. So this is the kind of profile if I want to draw the tension and compression. Are there any doubts till now? Any doubts? Okay, so this is the thing. What did I do? I analyzed this pre-stressed beam. For analysis, I just shifted this load P in the to the neutral axis, just to separate three things. First is the axial force, second is the moment due to the tendon, pre-stress force in the tendon, and third is the moment due to the UDL. So I consider these three cases separately. In the first case, I only consider this axial load. In the second case, I only consider the moment due to tendon, and in the third case I only consider the moment due to this UDL. Then I analyze these three cases separately. If I want to find the total force, then I'll add all the three cases. Okay, because analysis means we need to find the total force because of all this, right? So in order to find the total force, I'll add all the three cases. So whatever will be the answer, so by addition of this I can find the total force in the bottom part, total force in the top part, or anywhere in the beam. Okay, so this is the diagram for this. This is when I only consider the axial force, this is when I consider the force due to the tendon, and this is the stress when I only consider the UDL. The resultant stress profile will be like this. If I'll add all the three things, and I'll get the resultant profile. Okay, I hope this is fine. I just analyze. Analysis means finding the stress at any part of the beam. Okay. So by doing this, I can find the stress at any part of the beam. Okay. I hope it is clear to you. So this was the basics behind this analysis of pre-stressed concrete beam. Now, because most of the question they'll ask from losses, Okay, so losses are very important, just don't leave this topic. Okay, so losses. So what are the two types of? So there are basically two types of losses. One is the immediate loss, and second one is the time dependent loss. Just remember this table. One is the okay, Binoy, what is this? You want to ask something? You can unmute also. Oh, okay, no problem, no problem. Okay, so there are two types of losses. One is the immediate loss. One is the time dependent loss. Okay, so what are losses? Why are they happening? Okay, so when I just to yeah, so when I discuss this pre-tensioning and post-tensioning, so we intend to supply some, suppose we want to supply 800 kilonewton, 800 newton per mm square of stress in this tendon. Okay, but this sometimes this kind of sometimes this amount of stress does not transfer in most of 90% of the cases, or in most of the cases this the entire stress will not get transferred. Some of the stress will get lost either immediately, either during the transferring process only, or after some time, after like 4 or 5 years, some part of the stress from the tendon will get lost. So that loss we need to know beforehand, so we can take the measures for it. Okay, so the intention behind finding the losses is that we should know prior that this kind of losses might happen, so we will take into consideration that much losses. So either the loss can happen immediately or during this transferring of this pre-stress, or it might happen in the consequent years. So these are the two types of losses basically. One type of loss is the immediate loss, which happens during the transferring process, and one kind of loss is a time dependent loss, which happens later, like you have read about creep, shrinkage, that happens after some time, right? So this is the time dependent loss, and this is the immediate type of loss. We'll not go deep into these type of losses, just we should remember these elastic shortening loss, friction loss, and anchorage slip loss are the immediate type of losses. And from the name also we know that creep, that happens over time, right? Shrinkage also happen over time, and this relaxation happens over time. So these three type of losses are the time dependent losses, and these three are the immediate losses. So you might be asked in the MCQ also that whether this anchorage slip loss or friction loss are the time dependent losses or the immediate losses or something like that. Second thing we should remember from this slide is that what are all the losses which are possible in pre-tensioning, and what are all the losses which are possible in post-tensioning. So you can remember these letters. For example, for pre-tensioning, you can remember that ERSC happens in pre-tensioning. In post-tensioning, ERSCFA, all type of losses can happen. In pre-tensioning, only ERSC are possible. That is, E means elastic shortening, R means relaxation, S means shrinkage, and creep. So in pre-tensioning, the losses which can happen are, just remember this, elastic shortening loss, ERSC, relaxation, shrinkage, and creep. So please make these kind of short forms to remember, okay, because you cannot remember everything at that time. Just remember pre-stressing, ERSC, post-tensioning, all types of losses. Okay. So the third thing you should remember is that this thing I'll discuss, E star I have made, I'll discuss later maybe. So the third thing you should remember is that total possible loss that can happen is 15 to 20% of the initial pre-stressing. This question can also be asked to you. Okay. First thing you should remember is the what are the different type of losses, which of them are time independent and which of them are immediate. Just remember this. Second thing is what are all the losses that can happen in pre-tensioning, and what are all the losses that can happen in post-tensioning. So in pre-tensioning, there are less number of losses that are possible, and the names are ERSC, that is elastic shortening, relaxation, shrinkage, and creep. So this is the way you should remember these things. Okay. Okay, so now I'll discuss for this class. I'll only discuss this elastic shortening loss because we have very less time. Okay, so this is very common type of loss which is asked, and it is very simple to solve. Okay, because mostly the RCC related questions or the pre-stress related questions are very lengthy, so they'll not ask very complicated thing. Okay, so they'll ask just you know this thing, these things or not. So it's very simple formula. How do you calculate the elastic shortening loss? M into FC, where M is the modular ratio. Modular ratio, you must also remember from the working stress method, right? Modular ratio is simply ES minus EC, that is Young's modulus of steel divided by the Young's modulus of concrete. Very simple formula, right? M into FC, just that. What is FC? That the critical thing to find here is FC. Okay, so what is FC? FC is the stress in the concrete at the location of the tendons. So, okay, so I'll discuss one practice problem here, and you'll see that how easy this problem is. Okay, so the problem is a pre-tension concrete beam is pre-stressed. So this is the concrete beam which is given to us. The dimensions are 100. Just try to solve it with me. Okay, the dimension is 100 by 300 and let's mark the given things. Okay, so it carries an initial force of 150 kilonewton. Okay, eccentricity E, that is very important for us in pre-stress. E value, that is eccentricity. Eccentricity means distance between the neutral axis and the tendon. So eccentricity is given to us, which is 50 here. The modulus of elasticity of steel is given to us as 210, and modulus of elasticity of concrete, Young's modulus of concrete, is given as 35 kilonewton per square respectively. Now what do we need to find? We need to find the percentage loss in stress due to elastic deformation. Okay, so we need to find the stress due to elastic deformation. One more thing that is given to us is the area of steel, that is area of this tendons. Okay, so area of this tendon is given to us, which is 188 Newton, 188 square. Okay, so before starting any problem, especially of RCC, especially RCC problem, what should we do? We need to we need to note down all the things which are given to us. So that is the best way to approach any RCC problem, because there are a lot of data which is given to us. Okay, so area of steel is given to us, that pre-stressing force is given to us, E is given to us, ES and EC is given to us. Okay, area of concrete is, we can calculate, that is the area of this beam, which is 100 into 300 So we have calculated as 300 3 into 10 to the power 4 square. Now what can we do? We can find out the value of I. Why I? Because when we see here the analysis of this pre-stressed concrete beam, we see that we require the value of I, right? We require the value of this I. So we can calculate the I beforehand. So I for rectangular section is BD cube by 12. Okay, so first of all, let us find out the initial stress in steel. Okay, so initial stress in steel is force in steel is given to us. What is stress? Force divided by area. So initial stress in steel is given as, initial stress will be force divided by area of steel. Initial stress in steel. What is the value of force? I'm calculating everything. In that, this kind of problems, in the RCC problem, units are very important. Okay, because of that you can get some blunderous answer. So just keep in mind the units. So I usually personally calculate everything in Newton and square and So 150 into 10 to the power 3, I've converted it into kilonewton into Newton. So P divided by, what is the area of steel here? So area of steel is given to us as 188, right? Area of steel is 188. So what is the value of initial stress in steel? So the initial stress in steel comes out to be 150 into 10 to the power 3 divided by 188. So answer comes out to be 797.87 Newton per square. Okay, so first of all, we have calculated the initial stress in steel. You can do this later also, but I'll tell you later why do you require this initial stress in steel here. So the first thing you should approach is to find out the value of, so the formula, you know, you have to use this formula, that is loss you have to use this formula M into FC. Okay, so you should remember all the given things, and you should remember the formula which you have to use. So you have noted down this all the given things. Now you should see what formula you have to use. So you have to use this formula M into FC for loss, for calculating the loss due to elastic deformation. M, you know, M you can easily calculate ES by EC. All ES and EC is given to you. The main thing you need to do, you need to find out the value of this FC. What is the FC here? FC is the stress in the concrete at the location of the tendons. The stress in concrete at the location of tendons. So how do you calculate it? Okay, so here in this beam, what are all the forces which are acting? I'll draw this beam here. Okay, so this is the beam. What are all the forces that are acting on this beam? There is one neutral axis here. So there is one P here like this. Other than this P, we are not given that any UDL is acting or there is any dead load or something. We are not given anything like that. It's just that pre-stressing force is acting. You can also check there's no other force acting on this beam. Only this beam is there, and we are applying this pre-stress here. Okay, so these are all the forces. Okay, so the again the same step. What we will do, we will shift this load P here. By shifting this load, we also have to apply a moment, and the value of this moment will be, this is, we have shifted load, and this moment will be in downward direction. Why downward direction? Because we have shifted the load from the downward direction, because so the arrow will be here, and the moment will be PE. Okay, so there will be one P here and this moment PE. So this is the equivalent system. We can call it as the equivalent system. Now we know that what are all the forces that are acting. One is the axial force P, and another is the PE. There is no moment due to the UDL because UDL is not given here. Okay, so what we will do, we will find the value of FC using this formula. P by A, that is the force due to, stress due to the axial force, and the stress due to the PE, that is the moment due to due to this shifting of this load. So what is the value of P? The value of P is 150 kilonewton. We are giving the value of P. This is 150 kilonewton. I am converting it into Newton. Just do it with me, otherwise there will be no use of it. And second is A. What is the A? That is, this P is acting over the entire concrete cross sectional area, right? So the cross sectional area of concrete is 100 multiplied by 300. Okay. Another thing is the stress due to this PE. The formula is M by I into Y. M is P into E. P is 150 into E. E is 50 here, divided by I. I is BD cube by 12. Okay. So I'll calculate I quickly here. So I is BD cube by 12. B is 100. Depth is 300. Cube divided by 12. Right. So it comes out to be VD cube. Yeah, it comes out to be 225 into 10 to the power 6 mm 4. So this is the value of I. So I'll write it here, 225 into 10 to the power 6 multiplied by M by I into Y. So I have told you Y is the position where we need to find the stress. Here, where do we need to find the stress? We need to find the stress at the location of the tendons. Okay, so where is the location of the tendon from the neutral axis? The tendons are located at a distance of E. Okay, so I'll write E here again. So E is 50. Okay, so finally we will get the value of FC as 6.67 Newton per mm square. Okay, so now we have calculated the value of FC. So stress, we have calculated the value of as 6.67 Newton per mm square. Now, the loss due to the elastic deformation, the formula we know, M into Fc. M is Es by Ec. What is Es? Es is 210. What is Ec? Ec is 35 into Fc. Fc we have calculated 6.67, and final answer will be 40 Newton per mm square. Okay, so this is the value of stress due to the elastic loss in stress due to the elastic deformation. Very simple formula. So how will you approach this problem? So if this question is given to you, after if you read this elastic deformation, you have to calculate. So quickly this formula should come into your mind, that the formula is M into Fc's. Now you will find all the things which are required. M is either it would be given, or the value of Es or Ec would be given. So M is easy to find out. The main thing is the stress in concrete at the location of the tendons. Now in that in the gate, you do not need to shift everything. You would know that whenever there is a pre-stress, there will be a P and there will be a PE, right? Okay, so I'll consider this PA and PE. If any UDL would have been given, there would be one more term, which is M by I into Y, where M is the moment due to that UDL. Okay, so this is the thing you need to keep in mind. But here in our case, no UDL was given, so simply I've used this formula for calculating the value of FC. After I've calculated the value of FC, but here they are not asking what is the loss in stress. They are asking percentage loss in stress. So how do we calculate the percentage? This loss value divided by the initial value. So that is the reason I calculated the initial stress here. So the loss value is 40. What is the value of initial stress which I have calculated in steel? The initial stress was 797.87. So it is 797.87 and into 100 to calculate the percentage, and finally the percentage loss comes nearly to be 5%. Okay, so this, just keep this in mind. This will affect your answer if there would be just fill in the blanks type of question. So if they would you have calculated everything right, but you didn't see that percentage is asked, so you will write this 40. Although 40 answer is right, but they have asked the percentage, so you have to write 5% there. Okay, so this is the thing. These are the small things you need to keep in mind. Okay, now similar question have come in gate 2017 related to this elastic deformation. Okay, just I want you to try it yourself for just 2 minutes, and I'll solve it. Okay, whatever answer you could get till that 2 minutes time, you can tell me whatever step you are in. Okay, so question is, a pre-tensioned rectangular concrete beam of 150 mm wide and 300 mm in depth. So there's a concrete beam which is given to you. Similar question, very very similar. So it is 150 is the width and 300 mm is the depth. Second, and they are given, then we are pre-stressing it with three straight tendons. So I'm pre-stressing it with three straight tendons here. Okay, each having a cross-sectional area of 50 mm square. So each having a cross-sectional area of 50 mm square. So the total cross-sectional area of steel will be 3 times this 50. Okay, because there are three wires, so it will be 50 mm square. To an initial stress. So stress in steel is given. So stress in tendons is given. Stress in steel, you can write it is what, 1200 Newton per mm square. So these RCC questions are little boring. Okay, but no options. Okay, so the tendons are located at 100 mm from the soffit of the beam. Please note that this thing. Okay, so in usual cases, what do they give? This is the beam. Okay, and this is the neutral axis. Okay, and this is our tendon. This is our tendon. So in usual cases, what do they give? They give the value of this E, that where the tendon is located from the neutral axis. But in this gate question, they have told us that the tendons are located at 100 mm from the soffit of the beam. So 100 mm from the soffit of the beam means, what is the soffit of the beam? Soffit of the beam means, yeah, soffit of the beam means the bottom part of this beam. So this is the soffit. So tendons are located 100 mm from the soffit of the beam. So this is the longitudinal profile of the beam, and this is the cross sectional area I have drawn, right? So this is 100 mm from the soffit of the beam. If it is 100 mm from the soffit of the beam, and the total depth, and this depth, entire depth is 150, 300 divided by 2, right? So 150. So what is the value of E now? So the value of E is 150 minus 100, that is 50 mm. So they could have straight away given us the value of E, but just to confuse us, or in a hurry, you might consider this as the value of E. Okay, so you should keep these small things in mind. What is the thing that are given to you? Okay, so here it is given that the tendons are located 100 mm from the soffit of the beam. This means that the value of E is 50 mm, right? If the modular ratio is 6, so in here ES and EC is not given, they have directly given us the value of the modular ratio. And what do we need to find? We need to find the loss of pre-stressing force in kilonewton. Okay, here we need to do not need we need not to find the pre-stressing stress, loss in pre-stressing stress. Here they are asking the loss in pre-stressing force. Okay, so please keep, especially for the fill in the blanks type of question, keep these things in mind. Okay, whether they are asking the percentage loss, whether they are asking the loss in the stress, or whether they are asking the loss in the force, steps are all the same. Okay, but in the end you need to see these things. Okay, due to the elastic deformation, here also we need to find the loss due to the elastic deformation. So when you see the value of that elastic deformation is asked, the first thing that should keep in your come to your mind is M into FC formula. M into FC, this is the formula for elastic deformation. M value is already given here. M is the modular ratio, so M is already given, which is 6. The second thing is FC, that is the main thing you need to find out here. Second thing, one more thing you should check is, for finding out FC, what are all the forces which are given. Okay, so pre-stressing force is obviously there. So pre-stressing force is there. Is there any dead load which is given, or is there any weight of this beam which is given, or some other UDL which is given? If there is no such UDL or any dead load, then you can simply use the formula P by A plus P into this formula. To calculate the FC, you'll use the formula P by A, that is the axial stress due to the pre-stress, plus P into E M by I into Y. And Y here is the location of the tendon. So here the Y will be, you need to find the stress at the location of the tendon. So Y is E here. So this formula, quick formula, you should use. Okay, if there is no UDL. If there is UDL, there will be one more term. Okay, so very very similar question. Okay, so this, in the first step I found the value of this E, which is 50 mm. Okay, second thing is, we need to finally do this M into FC, right? For calculating the loss in stress, we'll use formula M into FC. M is already given, which is 6. Let us find the value of FC. FC will find P by A plus M by I into Y. What is P here? The value of P is, the value of P is not directly given. The value of stress is given. Stress is given and area is given. How will you will calculate the value of force now? So you know that stress is equals to force divided by area. So pre-stressing force will be pre-stressing stress multiplied by area. So I'll calculate the value of P now, which will be 1200, that is a pre-stressing force, multiplied by area. Area was 150 mm square. 150 mm square. The value of pre-stressing force which is coming is 180 kilonewton. Okay, so this is the force, value of force we are getting. Now we'll calculate the value of FC, which is P by A. P is 180 into 10 to the power 3 divided by area. Area is area of concrete. because we are finding the stress in the concrete at the location of stress, or at the location of steel. Okay, so since we are finding the stress in concrete, so we'll do P divided by area of concrete. What is the area of concrete? 150 into 300 cross sectional area, right? So it will be 300 into 150 plus m by I. M is P into E. P is this. So steps are very repetitive. P into E is 50 divided by I. I is BD cube by 12. Okay. So B is 150. D is 300 cube divided by 12 multiplied by E. E is 50. So this will be the final thing. So after solving all this, we are getting the value of FC as 5.33 Newton per mm square. Okay, so FC we know. Now we can easily calculate the loss in the stress. So can you tell me what is the value of loss you are getting by doing M into FC simply? Okay, yeah, it's right. Loss in the stress is 32 Newton per mm square. Second is, what we do not need to find the value of loss in stress. We are required to find the loss in pre-stressing force. So can you convert this stress into force? Yes. So loss in stress is given to us, that is 32 Newton per mm square. Now if we'll multiply it with the area of tendons, that is the area of steel, then we can get the loss in the pre-stressing force. Sorry, loss in the pre-stressing force, yeah. So what is the area of tendons? Area of tendons is, there are three tendons of 50 mm square area. So 3 into 150, and the final answer is coming out to be 4800 Newton. But we are asked the answer in kilonewton. So the answer will be 4.8 kilonewton. You should also keep that up to one decimal place they have asked. So you'll write 4.8. Okay, if they would have asked up to two decimal place, so you will answer 4.80. Okay, so these small things you should keep in mind for gate. Okay, especially for fill in the blanks type of question, many people do it rightly because there are no options. So this kind of unit problem or the final some small things they miss, or the answer will be wrong then. Okay, they, because they're not going to see your steps there. Okay, so I hope it is clear. So the time is less, so I'll not cover the next question because it is very very lengthy. Okay, maybe one more session I'll take for this pre-stress concrete, because there are a lot of losses here. Okay, so please practice these things. If there are any doubts, you can ask me. And if you want to solve, you can solve this problem as your homework problem. This is GATE 2018 problem of set 2, question number 46. This is a lengthy problem also, and it requires some different concept also, so maybe I'll cover in some other session. This, just note down this problem. Okay, whenever you learn a concept, right, if I'm teaching or if you are learning from somewhere, just find all the question related to that concept and see if you are able to solve it or not. Okay, because if you are seeing me and seeing me doing everything, then you will find it easy only. But if you'll do it yourself, you'll see some basic mistakes you are doing that time. Okay, so if there are no doubts, then I'll like to close the session for today. You can note this problem for your practice. Just take a picture and try to solve it. Let's see if you could solve it or not. Okay, any suggestions you can give me if you want to have some session for a particular topic or something? Otherwise, I think next session. Okay, because why did we multiply the area of steel? Because we need to find the loss of pre-stressing force due to elastic deformation of concrete. So loss always happen in the tendons. Okay, so the loss of stress, because we are stressing this tendon, right? We are not stressing. So these, whenever we are stressing this tendons, and this tendons transfer the force to the concrete, then so the whenever we need to find the loss, there always a loss in the tendons. Okay, so but so if we are asked to find the loss in the pre-stressing force, we will first calculate the loss of stress in the tendons, and then we will calculate the loss in the loss in the force in tendons. Okay, so since we need to find the loss in force in tendons, so that is why we multiplied the stress to the area of the tendons to get the force. Okay, so stress is force into area, right? Sorry, force is stress into area, right? That is why. Any other question, or is it clear? Or because since we need to calculate the force in tendons, so loss of force in tendons, that is why we multiplied the loss of stress to the area of tendons. Okay, if we need to find the stress loss in some concrete, not in this context, but in some other way in concrete, then we would multiply the loss of stress in concrete to the area of concrete, right? Or some other material. So here the loss happens in the tendons, therefore we multiplied, right? Okay, any other doubts? Okay, okay, then I'll close the session for today. Thank you for listening. And if there are any doubts, you can ask me. And if you want to cover any specific topic, then you can also ask me. Okay, okay, then thank you so much for listening. Bye.